Instacart is an American grocery delivery and pickup service. Customers choose items they want from a particular store through the website or app, and a shopper will accept the order, shop for the specified items, and deliver them to an address. Instacart needed a sophisticated prediction model for the availability of items in its retail partner stores to give them, the shoppers, and most importantly, the customers, the best possible experience. Using a binary variable not found, a shopper picking up items reports when one is not found in the store. An item cannot be found either if the product isn't in stock at a given time, which is availability, or if an item is too difficult to locate within a store and the shopper chooses to replace it due to delivery time concerns, or findability. Instacart's model can use not found reports on millions of items to estimate a product's availability and findability in a given store and in a given area. When a customer is choosing items, Instacart will show items that have a higher availability or findability to encourage customers to select more often available items. Additionally, Instacart will suggest choosing a replacement item for selected items that have low availability, allowing the order to be more closely tailored to the customer's preferences, as opposed to the shopper choosing a replacement for them, improving customer satisfaction.
Data summary, the model relies on three types of data called the item level features, time-based features, and categorical features. The data and item level features contains the variables of an item's historical found rate, the time since an item's last not found, and the expected time until the next not found for an item. The data for these variables comes directly from Instacart's shopper app as inputted by their shoppers. The item level features are important for Instacart so that it can relate to its customers the urgency of finding substitutes for their items over the course of the shopping day. The data and time-based features contains the variables, the time of the day and hours and day of the week that items are found or not found. The data for these variables also comes directly from Instacart's shopper app and allows for Instacart to track items' availability over time in order to recognize trends. For example, they encourage shoppers to order for the mornings when the shelves are fully stocked. The data and categorical features contains variables such as specific stores, products, retailers, departments, aisles, brands, and regions, among others. The units for these variables are the name they were given, and they take 1 and 0 as a binary variable. However, all this data is hard to obtain at the granular level and has high cardinality, meaning that there are many unique categories for each variable, which would make it very inefficient to put it in the model. Thus, they got creative, and for each of the categorical features variables, Instacart uses the historical found rate per brand name of all of those different variables. And by putting this data on a historical timescale, it allows the model to work much more fluently, and they can also account for seasonal items or items that are only popular during times of the year.
Now for a discussion on the data methods and models that were used by Instacart. So the main outcome variable of the model is a score that assesses the availability of an item. So this is basically a prediction of whether an item can be found at a given time. The main predictor variables of the model, or the feature space, come from the three categories of features that were described in the data summary portion of this presentation. And once again, those are item level features, time-based features, and categorical features. So obviously all of these variables are used to predict the value of the outcome variable for each item that the model is applied to. And now for the structure of the model. So the main goal of the model is to classify whether a given item is available at a certain time. And so obviously this is a classification problem because the main outcome variable of interest is qualitative as opposed to quantitative. So Instacart decided to employ a random forest model, which is a model that is built from separate decision trees that are each created using randomly selected subsets of the features. And then the overall model returns the classification that is selected by the most amount of trees. So based on the details that are provided in the article, we can assume that the model likely consists of three different trees, one for item level features, one for time-based features, and then one for categorical features. And then the overall model returns the classification that is then selected by the greatest number of trees for each item that the model is applied to. So some of the benefits of using a random forest model are that since the features used to predict an item's availability are randomly selected and are unique for each individual tree, this structure helps prevent the issue of the model overfitting its training data. And because of that, it also allows for lower variance and more accurate predictions than using a single tree would. Another beneficial part of this model is that random forests allow for ranking of features by their importance, or in other words, by their predictive power in the model. This is done through a process that involves error values that are associated with each feature as the model is trained to the training data set. So the ranking that Instacart released for the relative importance of each type of feature is that they found that categorical features are the most important, and then item level features and then time-based features were the least important in predicting the availability of an item. So in order to generate model parameters that accurately predict an item's availability, the model first has to be trained on a set of training data. So Instacart used data on previously ordered items and the outcomes of their realized availability in order to generate these parameters. The trained model is then applied to instances of items as users search for groceries on the website and generates predictions of their availability. This is ultimately done in order to organize the results displayed to customers on the website based on the real-time availability score that is predicted by the model.
All right, Lucas, here goes take two. All right. So now we come to the results. So before we dive into the results, we're going to look at a couple of figures that are visualizations of them. And so our key takeaways before we get into that, efficiency amongst Instacart shoppers will improve. They're going to save time. Improvement in customer experience. They're going to get more of the items that they selected to be delivered, less replacements. And just overall, the model is subject to improvement. The two main reasons would be data integrity and omitted variable bias. So before we go into those, let's look at figure one on the next slide. So looking at figure one, on the y-axis, we have the found rate, and on the x-axis, we have time in hours, and it goes between about 0 and 50 hours. And this visual shows us how findability changes over time. We can see a steep increase in findability if it is not reported as not found in the first hour, but this also reflects a low findability if it is reported as not found in the first hour. And then following this first hour, we can see a steady and consistent increase in findability with the time it is not reported as not found. So the first hour is very critical, it seems, for the findability. And then after that, it seems to be a clear, consistent linear relationship. So on the next slide, we're looking at figure two. And so on the y-axis, we have the availability score, and on the x-axis, we have the hour of the day. So this graph spans of one day. And so what we're looking at here is mostly the impact of the findability or found, not found classification on the availability score. So in this figure, it shows how findability affects the availability score of deli items specifically. We can see that findability is an accurate indicator for availability because the reported not found line up as what we would expect with the hours of the deli and the times they restock. So we can see that there's a found classification right after the deli is opened. And then later on in the day, there's not found, which is right before the time that they would restock. And then after they restock, we find that is reported as found again. And then again, it's the availability is going to decline right before they close. So let's return and look at the results that we concluded on about the model. So looking at the results that we can conclude, especially from these two figures, there are several key takeaways and insights. So first, there'll be a higher efficiency amongst Instacart shoppers. This is because shoppers will save time in the store since the Instacart app will direct shoppers to stores with higher availability scores for the items they requested by the customer. Also, the customer will choose items with higher availability scores since they'll be prioritized on the app. So they'll be more available, and shoppers will see these items first. So they're more likely to select items that will be found and available So they're more likely to receive that specific item. And this saves the shopper time in that they will find more of the items requested. And now moving on to improvement in customer experience. This model will improve this. Overall, more of the items requested by the customers will be delivered. As mentioned previously, shoppers will be directed to stores with higher availability scores. As a result, the shoppers will have to replace less items due to the availability of their original products requested by the customer. It would also prioritize higher availability items on the website and app. And this is for the customer to select from. So they're just more likely to select these items. And since the customer is choosing higher availability items, the shopper will have less items to replace, and in turn, a better customer experience because it'll save them time. So the customer will have their items delivered more quickly and more accurately. They'll get more of the items they actually wanted in the first place. And then just it's still subject to improvement. So while this model is helpful in many ways, it is still subject to improvement. First, the data source of the model could be improved. It is limited to historical data provided by Instacart, where other data sources could be found. For example, like if grocery stores kept track of sales, or just different data on how likely customers are to select certain items in the store, versus on an app, and kind of that difference between the in-person of the shoppers and the app itself, because right now our data is limited just to the app and what ends up being selected. And then the second thing that could be improved, and a thing of concern, is omitted variable bias. So as this is a new model, the features included are not fully understood yet. So there may be different variables that we're not taking into account. This also could be an issue of our data sources. However, as these features are further understood and this model is used on the app and website, features may be added to the model to improve accuracy and mitigate omitted variable bias.
So for our inference application, essentially the same machine learning concept utilized by Instacart currently to predict the real-time availability of grocery items can actually be expanded upon and further employed in other applications that could potentially generate new sources of revenue for the company. So in order to make predictions of the real-time availability of a grocery item, Instacart's current machine learning method gathers data on the sales volume of particular items in addition to some pretty other crucial variables. And in order to make this data operation more profitable, what they could be doing is they could combine sales data with customer keyword search data on the Instacart app for the purpose of selling useful information to partner retailers and producers and growers much farther up the supply chain. Of course, grocery stores do have data on the stocking and selling of their items and are able to therefore predict what items are getting pulled off the shelves more than others. But grocery stores don't have direct access to what customers are craving, for example. But I do think that Instacart's search data could help fill this gap in information. So, for example, here, let's say that there's a small Midwest town that is experiencing rapid urbanization and an expansion of corporate offices follows due to a recent technology boom. And let's say that the population of this town is going to attract workers from some bi-coastal tech hubs like San Francisco, New York, Silicon Valley, other places like that, where the demand for certain novelty goods and ingredients would be potentially higher compared to that of this transitioning rural town historically. So, as these new residents with greater sophisticated tastes flood the town, Instacart has an opportunity here to sell its search data for this region that highlights which sort of low in supply but suddenly high in demand goods. And we can say, for example, like black truffle mayonnaise or keto friendly pancakes or green superfood power for health juice and things like that. These ingredients might not be currently stocked, at least in abundance, in local grocery stores in this rural town. So this is an opportunity for local retailers to penetrate their changing and growing market. This same strategy can be employed for purposes higher up the supply chain as well. So in the same urbanizing rural town example, Instacart will be able to tell based on their own research data in correlation with with population growth, that demand for free range eggs as opposed to caged eggs, it might be sharply growing. And that would be due to the bicoastal areas like San Francisco, whose population are flooding this town, are going to have a relatively higher preference for environmentally conscious and humane sources of food. And this data might be of great use to farmers in the area too, whom Instacart might advise in exchange for some dollar amount, which would translate into more revenue for Instacart, to change the methods of raising and harvesting livestock. For example, chickens here with cage versus farm fresh eggs. In order to appeal to the region's growing selectivity and ultimately could help Instacart be more, or sorry, and ultimately to help farmers become more profitable as the population is changing regionally. And Instacart's machine learning driven availability score model, which is essentially the fundamental point of success in their machine learning method, this can be applied to many other businesses with similar markets and delivery platforms such as Amazon, GoPuff, Drizzly, which was actually founded by Boston College alums, and so many more too. So given that such companies operate over a wide geographical range, the availability of certain items will inevitably vary with regional discrepancies in, for example, supply chain efficiency and local craving and interest. However, by employing methods similar to that of Instacart's machine learning method, in order to derive the metadata necessary to accurately score findability of items, similar delivery companies like GoPuff, Drizzly, and Amazon, they might be better able to predict availability of items and offer more reliable marketing of goods that are both relatively highly demanded and easily found in certain regions. And the application of this model, it would benefit Amazon, for example, as warehouse stock likely varies according to regional differences such as population demographics, infrastructure, wealth, culture, local traditions, other variables like that. So I think it could easily apply to other companies in this case as well.
To improve the satisfaction of all parties involved in an order, Instacart created a predictive model to estimate a given item's availability and findability in a store using the number of not found reports from shoppers. Creating an estimated availability for every item allows Instacart to set accurate expectations for the availability of items and recommend appropriate replacements if they are likely to be out of stock. Using data on previously ordered items, data scientists at Instacart are able to train a classification model to predict the real-time availability of items based on the values of a large collection of features associated with each item. This allows them to organize items on the website according to their availability scores and connect users with items that are most likely to be available. The model relies on three main components of data: item level features, time-based features, and categorical features. The data for item level features and time-based features comes from the Instacart app itself, whereas they obtain categorical features data from the outside sources. The data for item level features and time-based features fits into the model well. However, Instacart's team had to adapt the categorical feature data to enhance the model's ability to predict the availability and findability of products. The results of this model provided insights to improve the customer experience and ways to improve the model itself. Customers' experience would be better as the products selected by the customer would have higher findability and availability through prioritizing specific stores and items. For the model, it can be improved by seeking out different data sources and a better understanding of the features for availability. The same machine learning concept utilized by Instacart to predict the real-time availability of grocery items can be expanded upon and further employed in other applications that could generate new sources of revenue for the company. The company could combine grocery sales data with customer keyword search data on the Instacart app in order to sell grocery stock advice to partner retailers and producers based on such information.